Okay guys, I'm going to talk to you about tolerancing. Tolerancing is all about how can we make stuff accurately. These two little videos here are good at showing you how you can literally get, as I've written, insane quality. Insane quality is literally what we're trying to do with tolerancing. But not everything has to have insane quality. Xiaomi will put cost as their priority over quality, whereas I don't know, these guys, they'll put priority for them is also cost, but it's also quality because they feel as though their priority is making sure they keep their reputation of making quality products, and then, and they cost a lot of money. So, where Xiaomi wants to be known as being affordable. So that's the decision a lot of manufacturers need to make when they are designing and making products is what sort of company do they want to be? Do they want to be accurate or affordable? Quality or affordable. Now, different materials have different abilities to be manufactured to levels of quality. Now, metals are the best mainstream material for getting exactly bang on dimensions. Now, I was making some notes here. Let's imagine we've got a billet of material here, which you can see. Now, that's got to be 110 millimeters long. Now, in reality, it's very difficult to get something spot on 110 millimeters. The reality is it would probably be something like, even if you thought it was good, it might even just be like that. It's very hard to get it. 110.0 recurring is literally impossible. So in that sense, all manufacturers and designers need to specify what is their tolerance, and that means what degree of imperfection can they cope with, can they tolerate. So if we've got a dimension of 110, we can actually look at it from this point of view. What would the upper limit of that be? So say if the manufacturer's tolerance window was, in fact, let's not work with such a ridiculously tight tolerance there. Let's make this more realistic. Let's erase that one as well. This is a typical question that you get in the exam. A manufacturer's tolerance is 0.5. Now, they would typically ask you with a dimension, what would be the upper limit and what would be the lower limit of what we call the tolerance window. So, all we need to do is either add tolerance onto the dimension or subtract it, and that's why it's got the little plus and minus there. So let's do the add first. So well done, you guessed it. It would be 110.5 millimeters would be the upper limit. The lower limit would be 109.5 millimeters. Now that makes up what we call our tolerance window. That's the degree of imperfection that we can tolerate. Now, with tolerancing and making stuff accurately, there's various ways of checking it to see how accurate it is. The most common one that we would use in school is vernier calipers. That's these things here. You might have seen these in the workshops before. These are great because they've got a digital readout screen and they are pretty accurate. They're accurate down to 2 decimal places, which is really good. So you can, armed with those, you can measure stuff very accurately. In terms of manufacturing metals to a high degree of accuracy, you need to use what's called a grinding wheel. So let's say you've cut something with a saw, it's been cut on the CNC mill. Afterwards, typically what would happen is it needs to go through a grinding process, and these grinders can grind surfaces down to pretty much like 0 accuracy. Like these machines can shave off, not even joking, like 0.0000001 millimeter. They can remove. So they work to crazy tight tolerances, and that's how you can achieve what is almost called zero tolerance machining, which you can see there. Okay, other checks they can use though, they can use lasers to check dimensions. So like I've marked here, you've got these, like, imagine those are lasers all firing at the part to check to see if the part is all the size it should be. You can use infrared as well. Infrared will literally just scan the whole thing and check the dimensions. Touch probes, like I've marked here with the green thing, these are like little sort of sticks that will come down and it will touch the material at various points around to check that all those key points are within tolerance. And then another one is called micrometers. Micrometers, you can see what those are in this video here, and that will explain them quite nicely for you. Okay, metals, you can see here, you can actually have almost zero tolerance machining. You can have invisible gaps. So this is where it's been machined to such a high level of quality where once these parts are all put together, you cannot see the joins between them, which is pretty cool. Plastics are kind of annoying. If you're injection molding plastics, it's very hard to have a tight tolerance because as plastics have been melted and when they cool, they contract. So you get these what are called sink marks here. And that's a problem with plastics, so it makes them hard to be precise with. If you're laser cutting acrylic, you can be pretty accurate, but because plastic melts when it's laser cut, it means that you're always losing a bit of dimension when you are laser cutting something because it melts away the material. Woods are another issue. Woods are great, but soft woods bow like that. They will literally bend in that direction and they'll also bend in that direction as well, lengthways. And that's as a result of damp, moisture, parasites, bacteria, whatever, fungal attack will cause them to bend. So softwoods, because the grain is so far apart on here, softwoods like completely are more susceptible to absorbing moisture than hardwoods are, because the grain on hardwoods is much denser, like that you can see. But it still happens. So when you're machining woods, you can actually have, with CNCing, you can actually have pretty high level of accuracy when the material is nice and dense. You can see all the grains here like really tightly packed together, so you can actually get a high degree of density here. Okay, then we can go on to the practice questions. So what I'm going to do is stop the video, you can have a go at the practice questions, and then I will go through them.